start out doing a little bit of review, because the hardest thing for most students to do when you're talking about indirect or direct and inverse equations is just simply remembering the equation itself. That direct equations are y equals k times x, and inverse equations are y equals k divided by x. Just keeping those separate, but even more than that, it's when we start solving for k. And that's why I want you really to be thinking when you're working these kind of problems, know this formula and then work your way backwards, not trying to remember what the equation for k is. Because I know you guys can work this. So the key is knowing these, that when they're solved for y equals, kx is directly connected, inverse they're opposite, okay? So let's take a look at our first type of problem. So we just simply want us to look at, are these inverse or direct variation, or are they neither? Because the first thing we need to do is be able to recognize what it is. So if we look at this first one, you can see, okay, is this direct variation? No, because it doesn't have it connected. They're in opposite locations, so this is inverse. But the key to looking at number 4 is looking at the equation. If it's not solved to y equals, it's not ready to be checked. So the first thing you got to do is divide by x to find that y is equal to negative 18 over x. And you can see that, again, that's inverse. Take a moment and see if you can figure out how to do number 7. All right, so you take a look at the first thing you had to do, honestly, was to get rid of the y on the bottom. So you multiply both by y. So you had xy equals 16, and then when you divide it by x, you get y equals 16x, and that's exactly what we're looking at for an inverse variation relationship. Let's take a look at it when we look at a table. So this is a little more tricky because we're really looking here at k. We're looking to see how are they the same. We were looking to see how are all these the same. Not are they meet the equation, but how are they the same. So when we look at our direct variation, I'm going to move this just a little bit down so I can write a little bit on the top. If we're looking at direct variation, we know that y equals kx. And when I want to know what k is, divide both sides by x, and I get k equals yx, y over x. So what I'm going to simply look for is that 20 divided by 1.5 is the same number as 6 divided by 5, or as 12 divided by 2.5, or 7.5 divided by 4. And that's not the case. If I look at this one, this is not 6 over 5, this is not 6, this is 6 over 5, but this is not. So if it's inverse, we're going to start off with that equation of y equals k divided by x. And when we solve this time we're multiplying by x on both sides. So xy equals k. Now we check to see if they're all the same way. So again, I start out here. 6 times 5 is 30. 12 times 2.5, well, half of that is 6. So 12, 6 is 30. 4 times 7 is that plus 2, that's 30 and 30. So this is another inverse variation. If any of these were different on both sides, then I'm talking neither. So let's take a look at the last one. So this is our chance. So we look here, we'll quickly check. We've got to check both of these on this one so we know which one's which. We check first, I check division first, and I always pick the easiest ones I can find. 36 divided by 3 is 12. 50 divided by 5 is 10. They're not the same, so it's not direct variation. Let's try inverse variation. 36 times 6 is 108. And another one over here, this is 250. They're not the same. So it's not division, it's not y over x, and it's not x times y. That's when it's neither. But when you're talking about these, you have to check both relationships. And then we're looking at our equations or our graphs here. We got to think about, all right, how do we do this? This first one, to keep in mind for direct variation, is it goes through the origin and it's a straight line. And it's a straight line. That's the key for direct variation. If it's inverse variation, we're in opposite quadrants. to make it pretty easy to look at, and it has that curved nonlinear shape. So, and then we're looking at neither, it's not through the origin. Or it's nonlinear and through the origin, it doesn't have that same shape. So you can see this is direct, this is inverse. And if you look at number 19 right next to you, you see that that's neither direct or inverse. Okay. All right, so let's move on to today's new topic. It's word problems. So I love these mainly because if I look at them, they tell me everything I need to know. Okay? I can look at them and go, okay, if I read carefully, it tells me the equation I'm using right here in this first sentence. Okay? It just takes a little bit of translating for you. So the first thing we need to think about is the computer income. The income of a computer analyst varies directly as the numbers of hours worked. So we know, first of all, it varies directly. So we know it's direct variation, so it's y equals kx. Now, here's the best part. Wherever it says varies directly or varies inversely, that's k. Everything before that is y, so in this case, it's income. Everything after that is hours. So they're hours. So that gives me my piece. Now, it wants the constant of variation, so it really wants me to solve for k. Anytime I see that, that's k. So I'm going to solve using my version of y over x. So I'm going to say y we saw was income, is 256, over x, which is 8. That equals my k. And I find out our computer analyst makes $32 an hour. All right, pause the video and try this next one. It's very similar in the same way as the last one. All right, now that you've taken a second to look at that, again, it has that same varies directly. It says very directly, except versus slightly differently. Water is my y, x is my minutes. So I know that I've got that same problem, 48 over 8 equals k, and we find out that k is equal to 6 gallons per minute, GPM. Okay. Now, the other type of problem I can ask you is a missing value problem. So one of the things that we know, if something varies directly, k is always the same. K is always equal to k. And that's kind of an example of the reflexive property. And not kind of, it is. So by using that idea, we can think this through. So if I know k is the same, whether it's this baseball game or the second baseball game, I can say that they relate to each other. And since this says varies directly, we know that k is y over x. So we know y over x is equal to y over x. And all I have to do is figure it out. Now the sales is our y. It says so right there. So it's 12,000 over 800 is equal to 15,000 over x. When I cross multiply, I get 12,000x equals 1.2 million. Make sure I get the right amount of zeros in here. 5 zeros. There we go. When I divide, cross out all my zeros. Leave that extra zero. There we go. So it's really 12,000 divided by 12 is, sorry, 1,200 divided by 12 is x is 1,000. Go ahead and pause the video and try this next one when it comes to ounces of medication. All right, so the ounces of medication varies directly. Again, there's that same idea. So we know this is our y, that's our x. So we know that 3/4, now you can change it. You can leave it as a fraction and do 3/4 over 120, or you could do 0.75, whichever makes you more comfortable. We'll use 0.75 because I know you all are more comfortable with decimals than you are fractions, is equal to y and over 200. So we multiply that. That really comes out to 120y is equal to 150. Divide both sides by 120. Cancel my zeros. 12 over 5. Y is 1.25 ounces. And you could have said 5/4. I'd accept both answers. So that's our varies directly set. Let's look at our inverse variations. So, and again, same setup. This first sentence tells me everything I need to know. That gives me the equation to write. It labels my variables, gets my let statements all worked out. Varies inversely again is k this time. So instead of it being y equals k times x, it's y equals k divided by x. So y is my time, x is my temperature, and this time I need to solve for k because again it's asking for that constant of variation. So I'll multiply both sides by x. So k is equal to x times y, which means k is equal to 300 times 3. So my k in this instance would be 900. All right, go ahead and pause the video and give this problem a try. All right. Let's take a look at what we've got. Again, we have that same varies inversely, so y is my cost, x is the number of people. So k is equal to 7 times 42, which makes k equal to $294. So the really neat thing about this is this makes perfect sense, because let's say you rent an Airbnb with a bunch of friends. The more friends you have, the cheaper it is. The less friends you have, the more you each individually pay. So that's kind of the idea of inverse variation in real life. Moving on to the other style, that missing style. So for that missing value style. So if we're looking at this next one, we're really looking at time traveling varies inversely with the average speed. So our idea goes behind this. Okay, well, the distance isn't going to change, and that's really what we have for k. So when we set up our equation, we know that k is equal to k just like before. But now we learned in the last one, k was x times y is equal to x times y. So here's my time is x or y. My speed is x, y. Sorry, this is y, this is x. So it's 65 times 3 is equal to 78 times x. When I multiply, I get 195 is equal to 78x. And I do my math, divide by 78. I know that it takes now 2.5 hours if I'm driving 78 miles an hour versus 65 miles an hour to get to this city. Saves me a few minutes. Go ahead and give number 11 a try and see what you come up with on this one. All right, so we have our same XY set. So 4 times 18 is 72 is equal to 8 times, I'm going to use W in this case just because it was width and length. Divide each side by 8. I find the width of my new rectangle is 12, is 9 something. We don't have a measurement, so 9 units. Okay? And that's everything we need to know. Be careful. Make sure you use that first sentence to work your way through it for which one's your X, which one's your Y, and use that to kind of think your way through it. All right, if you have questions, feel free to reach out. I'd be happy to help you. Have a good day.